This one's a real thick floor deck. We can put holes through them for utilities to go through, or we can actually pre-stress them. And I'm going to talk a little bit more about that in a minute. So we will use sometimes some precast elements. Now let's just go ahead and talk about it right now. Next page, figure 4230. Here is a beam that's got a little bit different shape. Okay? It's called an inverted T. I don't know if you can see that. And this one is pre-stressed. Now, what do we do when we pre-stress a beam? Let me kind of draw you a picture. What's the weak point of concrete? Tension. Tension's what we watch out for on concrete. So if we've got this huge beam we want to make, we want to protect it, so concrete's a natural source for it. What we'll end up doing is we'll take and pour a big beam like this. Okay, now what it's going to have some wire rope going through it. Okay? Probably right through here, and I'll just kind of put it like this. By wire rope, I just mean, cable, right? Now, this one looks a little bit different where they've got a bunch of rebar in this machine on it, but they use both. Okay. Now, what we'll do is we'll put this hydraulic machines on both ends. We'll fasten them and then pull them. And when we pull this together, the shape we end up with is this thing kind of ends up doing this. Okay. Where we put a little camphor in it, like a truck bed. But then we take these things and we stress them to way above whatever weight this thing's going to feel. So then as you go ahead and take this guy and we put a truck on it, okay? Here's a big truck. Let's see, should we make a dump truck? Yes. There's my dump truck. If that goes on there, it's going to push that down through the weight, but we don't ever let it get down to where it's back in this shape, because the wire takes it over. So in essence, what we're going to do is pre-stress it. We're going to put all that wire under so much force that it takes over for all the concrete. So the beam is constantly in tension and the wire is actually carrying the load. Now it's still protected from the elements, which is great. Going to last for a long, long time. Now this is real common for us to do in very, very large spans, okay, for us to do this. And in essence, you never have those cracks develop because the wire's holding it together. Okay. Does that make sense?
By a very large span, you mean length or
Yes.
width?
Length. Length. When we look at these common shapes that we use out there, which ones do we use as beams? Well, for the most part, we kind of think of the Eiger, the inverted T, the single, double, or the last one's a slab part. In essence, we're trying to get those moment forces. Keep in mind, when you're looking at these, like the F section, all the rebar is going to be down in here. Because as we deflect this thing down, that's carrying the weight. Now, just so you know, there is more rebar in it. We also put rebar right here, but that's usually just for crack control. It's not for the structural part. It's just kind of aesthetics. You'll see these shapes used again and again and again. They are tried and true shapes. Okay, so that's using it for beams. Columns. Concrete makes great columns. Let's go back to page 1065. Here you see a column that's going to probably be the interior of a building of some type. They've got a square formation on it. These things get very, very big and very high. We cannot make them all at one shot, It's kind of, I like this picture because you see it halfway through construction. So in essence, what they'll do is pour up to here. Okay, so this has all been formed with the rebar, then poured over with concrete. Now what's going to then happen is they're going to switch and they're going to start forming up this part up here above it, then pour that section, and then go up another portion and just keep going as they go. And basically you're unlimited on the size you want to go here. Certainly many of these skyscrapers have these type of columns in it. So that's a picture of one being done. So you can kind of see all the rebar in there where there's the vertical and horizontal that's tied in there. If you turn the page, you'll see the two different rebar tying methods where we've got a circular or the horizontal, kind of squarish one. So you can go either shape. And on page 1066 also, if you look down below, you've got some cross sections of what these look like in section. Okay. So this one's probably just carrying a load on the top, right? Just a one-type point load we're carrying across the top. This one is something like you would use in a parking garage. Where I'm coming up, I go ahead and give myself a little buttress that I can hang, some type of device off of. Think of platforms probably coming off of right here. Okay. So it just gives us an attachment device. You'll see these used especially where large buildings, or tall buildings, I guess I should say. Not large per se, tall. That's a real nice one to use. We don't really have any other pictures of stuff in there. Other than that, we certainly use it for walls and platforms. If you go back to 1065, this is something you see a lot of in our country. Just drive any canal bank and you're going to see quite a bit of this stuff. Because we use it to control water, also use it for buildings, these types of things. Here's one that's being poured in place. Okay. So we got a pretty big support structure. Concrete will be pumped in the top, let this harden for approximately 2-3 days, and then we can pull all the formwork off and it would be freestanding. There's a bunch of rebar on the inside of that. This is the finished product of the wall. All these little nails kind of look like they're nails coming out. Those are actually little things that are specifically designed for formwork. So in essence, you put the boards up, then you shoot these through with a magnetic gill and it holds those boards together in the middle through here so it doesn't fluctuate when it's drying. Because keep in mind, when you start pumping this full of concrete, concrete's pretty heavy. There's a lot of weight by the time you get right here. It's going to start bowing that out. Now, you can just leave these, or you can bring a grinder by and just cut them off real quick. A lot of them will actually even have a little tab on them that you can just bend it and they'll snap. Now, besides those are formed in place type of walls. And we do those when it's the cheapest alternative, we don't have a plant that can do it, or we have a hard time getting to the site. If we can get to a site, we'll use something more like what you can see on page 1069. Got two pictures there that we've got for walls. These are pre-manufactured. We call them tilt-ups. So when you hear the word tilt-up, probably most of you have heard that in construction. What's a tilt-up? It's a concrete wall that was built in some plant and shipped to the site. So here's all the formwork and rebar. So it looks like we got a garage door here, got maybe a man door here. Okay, there's a window or something. This is poured right here on the ground. Allowed to sit for a couple months, maybe a month, whatever the case might be. We haul it out to the site, we use a crane, and put them right in place. Makes for a great wall.
Why so long to sit there?
Because we needed to get to full strength so that when we pick this thing up, it doesn't break.
So it's full strength at 28 days?
28 days.
So as long as you wait more than an hour.
Yeah, and yeah, you might be able to pick it up a little sooner than that, because it's only carrying its own weight. I've used pre-tilt-up buildings. I've never built one, so I'm not sure exactly on that. I know they sit there for a while.
So tilt-up means that you bought it already concrete.
Right, modular system, right? Yeah, we do have a couple of these buildings in town, by the way. If you go out Washington Street, just before you hit Swenson's, there's a new plant. Well, it's the old Ridley's Warehouse. Plant Therapies in it now. That's a tilt-up building. If you ever get out there, you'll notice them because they're pretty ugly. They are. They just look like a gray cellar, you know, for the most part.
By the Swenson's in South Park?
Yes, right before it. So if you're crossing, you go, well, I can't remember. You're heading out Blue Lakes, right? Isn't that the right? No, Washington. But you cross the bridge, you go past the cheese places, you keep going. It's on your left before the stoplight, because Swenson's at the stoplight. Just keep looking on your left and you'll see the plant therapy signs on a big gray building that's just like this. It was built when I was a kid. I remember watching it. It was a tilt-up. Okay, so that's for walls. Now, one thing we don't see, when we're dealing with walls, keep in mind our rebar goes quite a bit smaller. I do have one thing on here. What about washed, stained, or stamped, or left alone? And these are all finishes. Okay. Concrete has changed a lot in the last 20 years. Many of you have heard of decorative concrete. Maybe you have some at your house. Makes a really nice finish on it, right? You've all seen washed concrete, I'm sure. Does anybody know what washed concrete looks like? You ever walked across the concrete floor and you see nothing but gravel, little tiny pea gravel, and like you're walking across the beach? We've got some in front of the Canyon building over here. If you go out and walk down those old steps. So what we do is we pour a slab. We wait till it gets pretty hard, probably about 8-10 hours, and then we bring a pressure washer off and we skim the top 1/8 inch off with water. And it just leaves a little aggregate right there and gives it a look like you're a bunch of gravel.
Is that like on the Spears building, like you know, on the top how they have it, it's kind of like, or not, the one over there.
Which building?
I think it's the Hepworth or the one next to it.
Oh, yes, yes, you're right. That one, I forgot about that one. It's the Hepworth building now. It has a bunch of washed concrete on it. And I think Shields does too, doesn't it?
Yeah.
I must be how my porch.
Yeah. You can do that with a garden hose. You kind of want a professional with a pressure washer though, because a garden hose you tend to get little holes.
How don't you with the pressure washer though? I mean, because it's so powerful, how do you know you're not getting one spot more?
Guys are good at this. You know, it's kind of like a painter. You look at a professional painter go and not a single run. Okay, these guys are good at it too. They just take it, just knock off what they need and walk away from it. Stamped concrete, we're getting a lot of that stuff now. All right, let's look at some properties of concrete. So whenever you are dealing with concrete, 2 numbers you need to know. Where do I got those? Right there. These 2 right here. Whenever you're dealing with concrete, the weight of it is 145 pounds per cubic foot. If we're doing rebar in it, or reinforced concrete, 150 pounds per cubic foot. Two last things you need to know about concrete when you're dealing with it. The old saying is, you only know 2 things about concrete. One, it'll get hard, 2, it'll crack. Well, when it cracks, how do we handle the cracks? Because it's going to crack. Almost all of it does. What we want to do is to mitigate the cracks. Now, mostly I'm talking slabs here. This is for slab design. You have a compression joint that you need to add to it. So in essence, we pre-crack it. Now the formula you use when you're getting into a slab for a compression joint is you take the thickness of your slab, which is usually in inches, times it by 2.5. That's the spacing of your crack in feet. So let's look at a little driveway. What do we mean by a compression joint? And how do we figure it? Okay, so what we're going to have for most driveways, we use a 4-inch slab. And what we know is this guy's going to crack somewhere, right? It's going to come in and do this type of thing. We've all been on those types of driveways, right? Where that has happened. Now, we still know it's going to crack, but what we want it to do is be kind of aesthetic and control it so that it still works as function. So what we end up doing here is we're going to take the thickness, which is 4 inches. We're going to times that by 2.5. That's equal to 10 feet. Okay, so what that tells you is that's your maximum spacing you can have in this concrete, or it's going to crack on you. So what we'll do, since this is 24 feet, okay, I know I can go 10 and 10 and then have a 4-foot piece. I would probably divide this in 3 because I can't make it in 2. I would do 8-foot spacing on my cracks. And so I'd come in here, go ahead and I'd bring a saw and I would cut this at 8 foot. Now I'd have to do it both directions, right? So it'd be another cut there, another cut there. And in essence, we're going to take that slab, make it into a bunch of little rectangles that work together. Now, what if you didn't want all those cracks on it? What can you do?
Break it on the bottom.
Okay, break it on the bottom. The same thing as saw cutting on the top. That's just a preference deal. If you use those breaker bars, that like we saw when we were touring, those will leave a hairline crack on the top. Saw cuts, a lot of people like those instead just because they're uniform all the way through. Okay, but they both do the same thing. Okay. Where's the variable in the equation? Yeah, it's a thickness, right? Okay, so if I came in and said, you know what, I don't want this thing all cut. I want it to be a little more aesthetic. Tell you what, why not go and do a 5-inch slab? Okay. Now what's your distance? 5 times 2.5 is equal to? Feel free to use calculator. 12.5. Well, look at, we're at 24 feet, right? Okay. So I can do this with one cut in the middle here, one cut this way. What if I didn't want to cut it at all? Keep up in that thickness till you get to where you want to be. Then it will have enough mass it can't pull itself apart. Which ought to bring the question, why is this stuff cracking? Anyway, got to crack in tension, right? So during the heat of the day, it gets hot. What do most things do when they get hot? They swell, right? They grow. So that slab goes into compression in the heat because it's pushing everywhere. What happens at night when it cools down? It starts shrinking and pulling itself back apart. That's when it's going to break. How thick would you have to be? Let's reverse this equation. And we'll call thickness X and say we want that to be 25 feet. Now you can figure out the thickness that you need to have for no cracks. what is that? 25 divided, have to be 12.5 inches thick. If my math is right. Which I'm not
Maybe
living.
just have to be 10 inches.
Is it 10 inches?
Yeah.
Thank you. To 25, yeah, got it. Do people do that? You bet they do. Okay, so that's one formula whenever you're dealing with slabs. The next one right here is this one. It's called your rectangle formula. And that is you cut it 1.5 times the short side. This is meant for sidewalks, decks, things of that nature. Are we doing a deck? Yes, we are. So we're going to have to look at this. So what you're going to do is just figure, whenever you have a rectangle slab, take the short side, times it by 1.5, that's when you need to crack it. Greatest example I can think of on this, everybody's walked on a sidewalk. About every third step, what do you have? A crack, right? That they put into it. It's based on this formula.
So what if you wanted to put rebar in your slab, would that?
Still gonna crack. Okay. Now the rebar is gonna take all the strength at that point. So it's still gonna perform. A foundation with a crack on it is still a good foundation. That rebar's got it. Okay. So it's no big deal if you walk up and you see a big crack through your foundation. As long as there was rebar put in it, hey, you're fine, your house isn't going anywhere.
So that's why when you walk on the sidewalk and it's also risen, is from the heat of the day and the,
No, that's probably something else. That's probably water in the soil swelling or something like that. But it's going to raise on those cracks, right? Yeah, 'cause that's where water is getting infiltrated in. Yeah, that's something else going on. Concrete won't move by itself. That soil underneath is what's moving. Okay. All right, so in essence, to summarize, cement, silica, lime, and clay. Concrete, cement with aggregate added. Bigger the aggregate, stronger it is as a general rule. We add steel to it, and we call it reinforced concrete. For design strength, we need to know that reinforced concrete weighs 150 pounds per cubic foot. Standard concrete weighs 145 pounds per cubic foot. I gave you the two formulas for compression cracks, compression joints, I guess I should say, that we have to apply into them. We use them for beams, we use it for columns, we use it for floors, we use it for walls. All of the above. It's basically our multi-purpose material. It's kind of my favorite material to work with. Probably because I haven't done enough of it. Because it's work. Yeah, I do concrete, but I've never made a living at it. Right? Those people that do concrete, man, I'll tell you what, they're tough boys and girls that do. Any questions on what we talked about? Okay, let's take a quick break. Now, for some of you to be thinking on, when we come to this, what we're going to do is kind of figure out what we got going here and how we're going to use concrete. So first off, we're going to put footings underneath this column, that column, and then these three. Those footings will be made of concrete, and in fact, reinforced concrete. So we need to design the size of it. We're also going to have a concrete deck up here. So we need to design that. We need, in essence, that's a pretty easy design. It's a matter of figuring out what type of steel decking that we need to go on top of it. Okay. So we're going to be using some of these values I talked about, and we'll go ahead and calculate this stuff up. So let's take a 5-10 minute break, and we'll come back, have your calculators and scratch paper ready to go.